Okay, this is the second video you're going to watch today, and I want you to make sure you pick up this worksheet from the counter, and this is 8.3, Area of Composite Shapes. And I want you to make sure that you hang on to this worksheet because I will allow you to use this on the quiz and test. So if you will please open your book to page 632. On page 632 at the top, you will see a chart that looks like this. So I'd like you to keep this out as we reference it. And for each of these shapes, we're going to first just write in what the formula is. So if we have a parallelogram, the formula for area, we're going to do a capital A so that we always remember area. And it's really important that you use lower cases b and h. Base times height, when it's lowercase, that refers to a two-dimensional shape. And what I mean by that is in a little bit, we are going to get into shapes like this that have 3 dimension, like a cone. And when we're talking about 3 dimensions, the base is then going to become this entire shape. And when we refer to that base, we're going to use a capital B because it's a 3-dimensional shape. And when we refer to this height, that's going to be a capital H. So it's really important that you get consistent now with using lowercase. So a parallelogram is a picture right here. So let's use your tools to add in. The first thing we need is a height to be given. And the height has to be a line that is perpendicular to the 2 bases. Now that's a brand new word. Perpendicular means that it comes down and it hits at a right angle. It is not this. This is considered the slanted height. That is very different than the height that we're talking about. So that's going to be considered the height. And either this or this are considered the base. Now, why do I say either one? Because in a parallelogram, they're exactly the same thing. Okay, so the area of a parallelogram is the product of the base times the height. Okay, so let's go over here. Let's draw this height in. Let's say this is 17.9 inches for a base. Let's say our height is 4.9 inches. You are going to calculate the area. Okay, let's go down here to triangle. The formula for a triangle is 1/2 base times height. Okay, so again, the height always has to be perpendicular. That means it has to come down and hit the base at a right angle. So you're always looking for this perpendicular height. And with a triangle, wherever the height hits at a 90-degree angle, that's considered the base. It's not always just the bottom. You could have your triangle drawn like this on a piece of paper. And even though this is what we see as a bottom, we locate the base by wherever the height hits the line perpendicularly. Okay. All right. So if you look at this problem, this is really nice because one of our sides is already our height. So let's say that this is 12 inches and this is 8 inches. And this is 14 inches. You have to be able to spot in a problem like this where the perpendicular sides are. Perpendicular means 2 sides that form a 90-degree angle. So you have to be able to spot that since 12 is perpendicular to 8, that means 12 is our height and 8 is our base. In this case, 14 is completely unnecessary. It's not a value that we even need to use in terms of area. Okay. I'd like you to really quickly just draw a small triangle down here because I want to show you one other thing that sometimes textbook writers do. Sometimes they'll give you the base like this, but instead of drawing the height right through the middle, sometimes you might see them do this. Okay, and I want you to realize that that is just a different way of expressing the height right through the middle. So instead of drawing that perpendicular height through the middle, they'll kind of pull it out here. And with dashed lines, they're kind of showing you that that's the perpendicular height. Okay. All right, so you're going to finish up that problem as well. Okay, let's go down to a trapezoid. We've been hitting trapezoid over and over again the last couple days, but we're going to think of the area of a trapezoid. This is how your book writes it. They say you take 1/2 of the two bases added together, then you multiply by the height. Okay, so over here with your straight edge, we're going to draw in a perpendicular height. And we're going to label this base 1 and base 2. Okay, now I spent a lot of time the other day talking about what we're really doing is we are averaging the bases. We are finding the average of the two bases. So another way you can write this, and it means the same exact thing, is averaging. Don't we add the two bases up and divide by 2? And then we multiply by the height? So this formula and this formula mean exactly the same thing, because we've learned previously that dividing something by 2 is the same as multiplying by 1/2. Again, pause the video if needed to catch up on these notes. So let's be tricky here, and let's say that they give us this height by measuring out here. So sometimes a textbook will do that. So let's say that the top base is 26, the bottom base is 17, and the height is 19. So go ahead and calculate this area. So I like to do this. I average the bases. So I add them up and divide by 2, and then I multiply by the height. All right, and we get down to circle. So the area of a circle is pi r squared. So that means you have to know the r, the radius. Remember that if you are given diameter, you must divide the diameter by 2 to get radius. You must do that first before you plug it into your problem. Okay, and you can go back and pause if need be. So let's do 19.6 inches over here. So go ahead and find this area. So 19.6 divided by 2 is 9.8 squared, and you're going to get your solution. Okay, this page is going to be a huge resource for what you're getting into today. So on the bottom of page 632, take a look at what they're introducing. This is called area of composite shapes. A composite figure is just when you take two separate figures and you glue them together. So notice that this shape is a semicircle attached to a triangle. So what you're going to have to do is break this problem down, and you're going to have to focus on one piece first. So if you focus first on the semicircle, which is what they did, you find the area of the semicircle. Then you focus on this part, which is the triangle, and you find the area of the triangle. Since it's a composite figure, that means we're adding both pieces together to get an answer of 47.1 square meters. Okay, so let's go down and try Got It question A. So please pause the video for a minute, and I'd like you to sketch down here what you think the two shapes are that you're going to use. Okay. If you're stuck, let me suggest that you look at this as a trapezoid stuck on top of a rectangle. Okay, so the first thing we're going to focus on is this rectangle. So the area of the rectangle is base times height. So we do 13 times 25 is 325. So that's this bottom. Then we're going to add to that the area of this trapezoid. Well, I see the top base is 20. I see the bottom base is 25. But how do we know what this height is? 20 is this entire part, and 13 is this entire part. So do you see that this has a difference of 7? So we are going to add up the two bases and divide by 2, and then multiply by 7. And I got 157.5 for that top piece. So our composite shape is when you add them together, you should get up 482.5 inches squared. Okay, turn the page. And if you look at Got It question B, where is it at? There it is. Okay, this one's a little bit easier to see the two shapes that you're dealing with. So we've got a rectangle attached to a triangle. So you would do 15 times 2, that's the area of the rectangle, plus area of this triangle. And notice here's an example. They labeled it out here. So the height of the triangle is 4. The base of the triangle is right here. That's 15. So we're going to do 1/2 of base times height. So calculate all of those and see if you get this answer. Okay. All right, look at this last example, because sometimes you won't necessarily want to look at two shapes being put together, but a shape that has some things subtracted. So do you see that this shaded area is basically one giant rectangle with these little triangles cut off the edge? Okay, so if you look at the work that they did, the area of the rectangle, the whole rectangle is just 12 times 5. But then if you focus in on this triangle, isn't this triangle here have a base of 1 and a height of 1? So we do 1/2 base times height. So 1/2 of 1 times 1 gives you this area. So 1 times 1 is 1, times 1/2 is 1/2. So that means we have 1/2 here, 1/2 here, 1/2 here, and 1/2 here. In other words, we have 4 halves. So that means we have 2 square inches that have to be subtracted off of our full rectangle. So if the full rectangle was 60 square inches, we need to subtract 2 to get 58 square inches. Okay, I know that this is going to be a challenge. So on page 635, you are going to do, so I'll write it right here, your assignment is page 635. We're going to try 1 through 9. And then you're going to do 22 through 27, which is mostly review. Okay, be good, and I will see you Monday.